dawn of time, humans have been touching things. We touch each other. We touch door handles. We touch our food. We touch our pets. And we even touch ourselves. Computers typically use a keyboard and a mouse to interact with the user interface and access files or create documents. So now imagine, instead of having to use the computer and type something out or move the mouse to use your cursor to point to something, imagine if you could just touch the screen right where you want to be and do exactly what you want to do. This is usually accomplished in one of two ways, with capacitive touchscreens or resistive touchscreens. To help me explain the differences between resistive and capacitive touchscreens, I've got Matthew M., the ELEC friend, here to explain.
Thanks, Chris. Matthew M., the ELEC friend here. Resistive touchscreens consist of two layers, the conductive layer and the resistive layer. The resistive layer consists of a more rigid material, like glass. Both layers are coated with a thin layer of conductive metal, most commonly indium tin oxide. The conductive and resistive layers are separated by small, non-conductive points in the space between them called spacers. A voltage is constantly applied through the conductive layer. When the user presses between spacers, the resistive layer bends until it makes contact with the conductive layer. This changes the voltage at the point of contact, which allows the processor to calculate the exact coordinates of the location of the touch. Because resistive touchscreens rely on force to bend the screen, they can be used with fingers or other objects like a stylus. They support basic single-finger touch methods. Because they are durable and cost-efficient, they tend to be used for surfaces that expect a lot of wear and tear, like checkout monitors at stores. Capacitive touchscreens function by creating an electrostatic grid of tiny wires that run vertically and horizontally across the screen. This creates an electrostatic field at the intersection of the vertical and horizontal lines made by the wires. The controller identifies these points of intersection as neutral. The human body has a natural capacitance, meaning it can store electric charge. Because of this, the touch of a finger at an intersection in the grid disrupts the electric field. The controller can detect this change in electric field and identify the point of contact. Because the lines of this grid are super thin, capacitive touchscreens are very accurate. So those are the basics of how touchscreens work today. Say, Chris, do you know anything about where this technology is headed in the future?
I sure do, Matt. While touchscreens have come a long way in terms of accuracy and durability, the industry is constantly trying to keep up with the rapidly changing consumer tech landscape. One primary way that touchscreens are adapting to user demand is flexibility. By using silver nanowires as a conductive metal rather than indium tin oxide, scientists are working to make touchscreens that are brighter, cheaper, and more flexible.
That flexibility sounds like it could make touchscreens really durable. It could also create some really cool wearable devices.
Another example of how touchscreen technology is advancing is haptic feedback technology. Haptics is a science of applying touch sensation and control to interact with computer applications. Most famously, the iPhone 7 replaced its home button with simple glass connected to a haptic motor. Haptics allows users to receive feedback in the form of felt sensations. Currently, the most common way this is accomplished is using advanced vibration motors, much like the one in the iPhone 7. Haptic feedback is already allowing users to perceive textures and contours of objects by making a screen feel smooth, bumpy, rough, or even sticky.
That could be especially useful for tasks requiring hand-eye coordination. Surgeons could perform remote surgery where they could feel the skin while they operate. People playing online tennis games could feel the impact of the ball as they play. The possibilities are endless.
Thanks for watching, everyone. I'm Chrissy the Double E, and I'll see you next time.